So hello guys, in this video I'll be explaining you the working of the task SAN.1D, how the system design in the SAN.1D task works as a whole and everything, the underlying principles, the software code, hardware setup, and the working of the system. So first of all, let's talk about the what the task requirement is. So the task requirement was pretty simple, that we have to just give an audio command through a microphone to the Raspberry Pi. It will process that command, and using that command it will just turn on or turn off the LED according to that command. If we'll say turn on the LED, it will turn on. If we'll say turn off the LED, it will just turn off. Okay, so this was the task requirement. Pretty simple, not a great, but still it was challenging to do. So now let's talk about the hardware setup. What the hardware setup was. So the hardware setup you can see on the screen. Let me check if you can see. Yeah, so you can see on the screen the hardware setup here. So this is our Raspberry Pi 4. This is our LED, and this is our and then these are connection using the jumper wires. We have connected the anode to the GPIO pin 11, and we have connected the cathode to the GPIO pin 39, which is our GND pin also. Okay, so these are just basic, and also the headphone setup, which will be headphone or the micro, which has a microphone which will be used for giving the commands to it, and using that command the Raspberry Pi will process it. Okay, so we have talked about the hardware setup. Now let's talk about what the softwares we have used. The softwares that we have used in this are basically, we have used the three libraries, out of which is one is the speech recognition library, which is used for the same purpose of to just recognize the audio what we have said, and sends it to the Google API, and using that it will just process, or it will just recognize what we have said, and what everything that has been told in the microphone. It will just process that speech, if you know what I'm saying. And which I will also show how this speech recognition library will work in our code and our embedded system design that we have designed here. And in simple words, if I should tell you that it converts the audio input from the microphone to readable text using Google Speech to Text API. It uses the Google Speech to Text API, and then converts the audio input from microphone to readable text. So another library that we have used is the Pi Audio library. It interfaces with the microphone at the system level to provide audio streams. Like the Pi Audio library, how it works, if I'll explain you, it just connects to the microphone at the system level, and it will provide the audio streams to the speech recognition library. And RPI.GPIO library we have used to use our these GPIO pins in GPIO pins, and provide signals like GPIO high, GPIO low to our LED. Okay, so now let's show you the software code that we have used here, the code of our system. Here you can see the code here. So this is our speech recognition library, you can see. And this is our RPI.GPI, we have imported them. And these are time library for delays and for seconds, etc., to define that. Okay, so this is our code for we have just set up the connection, like the LED pin is connected to GPIO pin 11, and we have connected GPIO board set mode, which is used for connecting to the pin, like it's 11 pins, so we'll just specify 11 here. And we have, by default it is initially set our LED to off. Okay, so this is the code for LED defined for the recognition, or we have, or to use the speech recognition library to process what we have said, or to recognize what we have said, to take just the input of our voice. You can see here, it will just take the input of what we have said. And this you can see here. Yeah, so it will just recognize here, and it will sense it in a command, which will it will see that what command we have given. If we have said turn on, it will see say it will just recognize we have, if we have said turn on, if anything we have said, it will just process what we have said using these lines of code. And it will send using the Google Audio or the Google API which we have used. This is just a syntax for this library, if I'll say. So what is this control LED? So we have given the input. What about the output? So the output part will be handled by these lines of the code. Like if we said the turn on, then the LED will be glowed up. If we'll say turn off, the LED will turn off. Here, and if we'll say anything else, then it will say that it was not a valid command, or command not recognized. We'll just say turn on or turn off in order to do this. And this is the line for that it will work in a loop. This all thing will work in a loop, and it will just at the end it will the GPI cleanup will just do the final rated job, and everything it will just close and everything will be clean. And using a keyboard interrupt, we will just click on the keyboard and it will just the program will just close or just shut down. It will not work further. Okay, so this is our whole code. It's a small piece of code. Okay, so now let's talk about the working of this task, how this system works. Okay, so let's talk about how the system workflow is like. So the system workflow is like, first of all, we'll speak what will turn on or turn off the light, we'll speak it. And then the speech recognition library will use that speech, and it will convert it into text using the Google speech to text API. And then what we have spoke that text will be used by the Python, or the Python will use it in order to see what we have said. So what we have said will be then further used for giving the output from the GPIO pins by setting them high or low accordingly, and setting the LEDs to turn on or turn off accordingly. So nothing much. It follows a very clear protocol pipeline. The microphone captures the analog audio and digitalizes it into a form Python can process. The speech recognition library sends this audio to Google's API to perform speech to text conversions, and this pass text commands will dictate the GPIO pin states, which will control the LED hardware. Okay, I have explained the code, everything. Now let's see how the task, or how the working of this task is like. So first of all, let's go to our virtual environment. So what is it's you will ask what I have done in these lines of code, what I have done this. So I have created a virtual environment in my terminal or in my Linux in on which this Raspberry Pi works. So what was the point of this? Why we have created it? So when I was just normally working or normally running this piece of code, not in a virtual environment but by just Python, or Python, this audio script.py, it was not working. It was showing some errors. So doing some research, I got to know that I should use the virtual environment. And why I should use this virtual environment, as it will isolate the project dependencies so they don't conflict with the other system Python packages. And it will allow a safe installation of required libraries like the speech recognition, PyAudio, Raspberry Pi.gpio, RPI.gpio, and it is also easy to manage and replicate for our future uses. And also one more thing to mention, which I have not mentioned in the software, is what softwares we have used. So another utility that I have installed in order to process this audio in a very good and in a very clean way is the FLAC. So what's FLAC? So this FLAC is a free lossless audio codec. It's a library or a utility in which using which the speech recognition converts this raw audio and I use it to this FLAC, and before sending it to the Google speech recognition API. Like FLAC, it's just compresses the audio while retaining its quality, and it optimizes its upload size and recognition accuracy. And we can use this or install this FLAC using the sudo apt install FLAC on this Raspberry Pi OS. And without this FLAC install, its chances are very much that this transcript process or this transcript processing will might fail, or it will not recognize what we have said in the microphone what we have said in the microphone clearly. Okay, so let's see the working of this task. Yes. Okay, so let's just I've entered my virtual environment here, and then I will just go to the folder where I stored this file. Then I'll just run this file, this python audio script.py, you can see on the screen here. Or then I will just run it. Now you can see how this goes. Let me show you like this. If you can see on the screen here. Okay, so let's say turn on. You can see on the screen that the LED has just turned on. Okay, now let me show you once again. Turn off. You can see the LED has turned off successfully. You can see here it is connected perfectly to the Raspberry Pi, and this is working. Turn on. Yes, you can see it has turned on. Turn off. Let's do it once more again. Turn on. Turn on. Turn off. See, perfect. So you have seen how this thing works. Now let's just do it. Just move it. So you can see how this thing worked, everything. And this project, what was the purpose of this project? So this project helps us to combine this hardware and these software utilities and libraries, etc., to create a smart voice controlled embedded device. Like you can see, whenever we in smart homes we say turn on the light, it just turns on the light. And so it's just like a smaller and a very compact way of showing this thing using or to create this thing using our embedded system. So we also created this thing with thoroughly understanding of the audio capture protocols, cloud API integration using of library, GPIO control. And also we also demonstrated this working of the task in a very great way, and using the selected libraries and tools like speech recognition, Pi Audio, RPI.GPIO, FLAC. These were chosen based on the official documentation and also on the researching on Google, etc., in order to see how we can establish this speech recognition LED turning on or off, or what's the product's practical suitability for this Raspberry Pi project. So I think I have explained everything top to bottom in a very great way and in a very good way. And I hope you like this video. Thank you.